What I have here is a physical representation of our celestial sphere. So we talk about the celestial sphere as always just kind of appearing as if it was just some ball that surrounded Earth, and we can absolutely represent it like that. So what I have here is Earth at the center. So if you look closely, I've got kind of our map of North America there. We got the rest of Earth on there, and you can see on the surface of this are all the constellations, and we can keep them fixed in that same way, and see what's going to happen with our celestial sphere as it moves a little bit. So I've left the Great Lakes region just kind of on top. And so we can imagine that if we're standing there on the top of the earthen globe there on the inside, everything that's above or in this top half of our celestial sphere is what we would see at any given time. Now, the celestial sphere does appear to move, and in this case, our celestial sphere is bound by our north celestial pole and our south celestial pole, and they are tied right into Earth's north and south poles. And so the celestial sphere is just really an extension of the key points on our celestial sphere are just some extension of some things we have on Earth. Similarly, the celestial equator, which is this thick kind of line here, it's actually just where the molding is on this translucent globe, is just an extension of Earth's equator. So if I pull this back out again, you can see the red line of Earth's equator there, and kind of aligns with the little molding seam here where the stars are. So we have all of these key points, and the celestial sphere appears to be moving around Earth. Now, in reality, it's Earth is really what's spinning, and so our perspective changes. However, in this case, it's a lot easier for me to kind of move my celestial sphere around, whereas reality, it's Earth that's moving, but we'll keep on addressing that. So in this case, as the celestial sphere moves, if I kind of keep track of where I'm at on my celestial sphere, it'll actually spin around entirely about once every day. So every single star that we could possibly see is actually visible to us once a day. Now, doesn't mean that we can see it through the atmosphere, of course. The sun being high up in the sky makes the sky blue and makes our atmosphere not easy to see through, particularly not for relatively faint stars. But those stars are still there. Now, when the sun goes down at night and we don't have the glare from the sun that's consuming our atmosphere, of course, we can see everything. And so the celestial sphere, we can always just kind of inscribe all of the details. So all the constellations, most night sky objects, we could just put on a map. So the dots on here, I could take this celestial sphere, go back a couple thousand years, and it would still be an accurate representation of the sky. Most notably, what we cannot accurately represent on here, or at least not put on a map, are things like the planets or the sun and the moon. There's a little more complex motion involved there because they are close enough to us that they tend to travel through the sky a little bit more. And they travel on a line that we call the ecliptic. It's kind of a not too far from the celestial equator, but it's on the celestial sphere here, and it's kind of offset. So everything from the sun, moon, and planets is on that ecliptic, which is just another element of our celestial sphere.